do it again. Just didn't put away your own damn book. I mean, it was on your desk, so my favorite.
Yeah, exactly. Shaw like said something stupid, so I was like, "Isn't Shaw not supposed to have anything besides water?" And he goes, "Oh yeah, that is true. You guys all need to put your drinks on the bag." Man, and then George was, this will consist of two parts. Part one is just the old Algebra 1 warm-up part. And then part two, this will take a couple days because we're going to do some simple algebraic ones today, and then they'll become a little bit more complex. Not sure the order, but I think tomorrow or Wednesday will be the more complex ones with like roots and things like that. Anyways, there'll be another version of this to come. For today, you'll remember from algebra that evaluating a function, here's a function, something like this. And in the first class that you and I had together years ago, we evaluated the function like this. We would say, okay, there's a function. What's the name of that function, by the way? You remember?
A linear function?
Sorry, that's a really bad question. The name of the function is f, and it is a function of x. And what that means is a function that says feed me x's. Like whatever you want me to do mathematically, feed me some numbers or a number, and I'll put it in place of all my x's and beep boop boop boop, you got an answer and spit it out when I'm done. So a function, remember, is just a little dumb machine. Like in this case, this function's name is f, and he processes x's. Got it? So the name of the function goes first. And remember, we don't say like fx, we say f of x, the word of of. So anyhow, this is the function f of x, and I would have asked you back in the day to evaluate it. So something like this. What is f of 3? Do you guys remember how to evaluate a function?
Just plug it in all the actual.
Yeah. So this is our little warm up here. It'll take about 5 minutes. So I'm going to plug 3 in place of all of the x's. So wherever these little yellow arrows are pointing, we're going to essentially turn those into the input. This function just says feed me whatever. We give it a 3. I'll give you a quick second to work that out. What's that going to be?
18.
What do you think it is?
18.
It's like your final answer?
Well, 3 times 3 is 9 times 2.
Yeah, just the final answer is all I need.
Oh. 11.
Thank you. It's like pulling teeth. If you didn't get 11, either you're still working or you boo-boo the order of operations. But you should have done the little green jelly bean first. Remember that? 3 squared is 9, 9 times 2 is 18, so on and so forth. So, and we can also do this with negative numbers. So what if I asked you to find like f of -2? Again, I'll give you a moment. I'm going to go shut the door while you work that out. Let's see, what's this one? 8. What'd you guys get for this one?
21.
It is indeed 21. And again, I would say that if you didn't get that, now would be a great time to advocate for yourself in the form of asking why. Good, good? You good back there? CG, you good? Okay. So I don't think I need to practice that again. The only other one before we get into the actual lesson is I know that in the past we've had trouble with functions like this. What's this function's name? His name is G, and he processes M's, right? So he's a function with input slots, and I should not have put G of M and then put X's. That was really stupid. So we're going to do this, and we're going to fix this. Okay. That was my bad. The as you saw from me just now, you learned this has to match your input spots over here, right? That seems kind of obvious to everyone other than me. So let's find g of 4. The answer is definitely negative 4. So again, years ago when we first met, you would have fallen for traps like that, but you're wise now and you understand that when you put a number in place of m, you evaluate the jelly bean first, right? You remember this, you've heard this lecture before, how we kick the negative off to the side. Um, Negative 4 squared is 16, or 4 squared, excuse me, is 16, and then you stick the negative on it when you're done. So yeah, I don't feel like you guys need any more real work with that. All the traps I've set for you, you haven't fallen for. So do you have any questions so far? Okay, so let's get to what we're actually doing today. So what's going to happen at some point, I'll just kind of tell you a little background on this. Eventually, I'm going to give you two functions. Don't write this down. I'm going to give you two functions like f of x equals like x squared minus 4x plus 2, and I'm going to give you another function named g of x equals I don't know, like negative 2x squared minus 3x plus 1 or some nonsense like this. And I'm going to ask you if the functions are inverses of each other. And what I've learned about this is when that time comes, we're still probably a week away from that conversation. But when that time comes, if we're mechanically prepared to not be burdened with, again, just the plug and chug algebra kind of stuff, that lesson tends to go a lot better. So the purpose of today is we're just practicing with mechanical skills, just some, like, bless you, just some drill and practice repetition so that when the time comes to apply the concept of composing functions and putting algebraic things into functions, that we don't have to slow down for that. So just so you know why we're doing what we're doing today. So for today, I have 5 examples, and then I have a new assignment for you, and that's it. So here are my functions. My first one, I have named k. He is a function of n, and he does 5 times n minus 11. And for the first math problem, I would like you to help me find k of negative 3 minus n. Okay. So I don't know that we've ever really gone down this road. We might have dabbled with it a bit, maybe in the days before ninth grade Y-top or something like that. But what's the deal here? How's this going to work?
You just slap that baby in.
Yeah. And so algebraic inputs, get used to this, are like Zane very eloquently stated, just slap that baby in. So we're going to take this right here, what I'm underlining in green, and we're going to put it in place of this that I am underlining in green. I mean, functions are very repetitive. They sit there with variables and say, feed me, feed me. And so we're going to rewrite the function k as 5 times input slot minus 11. That's all we're doing is evaluating a function. The difference is from this point on in today's lecture, your answers aren't going to be numbers. Your answers are going to be algebraic expressions. If you feed a function an algebraic expression, it gives you back more often than not an algebraic expression. So let's see what happens. If I change the input slot into negative 3 minus n, I just do a little bit of basic math, right? What do I get? Right. And I'm just going to not go quite that fast just in case I don't want to lose anybody, but yes, absolutely. So it's just basic algebra distribution and then combine like terms. So we would generally, as a matter of practice or like habit, we would put the variable part first. So we're going to say that k of negative 3 minus n up here in the corner equals negative 5n minus 26. Got it? So algebraic input, algebraic output. Here's our next function. His name is p, and he is a function of t. And the function takes your input and squares it, and then subtracts twice whatever it is, and then adds a constant amount 4. And we are going to find p of negative 6n, negative 6t, excuse me. And honestly, if you don't mind, I assume some of you take your notes in pen or pencil, but just for the record, I'm going to color code this for you. What I'm underlining in purple has to match what I'm underlining in purple. And more often than not, you're going to see that the input is going to match. But just for the record, I could have put, what did I have here? -6n originally. I could have left it like that. Just for the record, as long as the purple ones all match, like your variable that you've declared as an input has to be what's in the function machine, but then you can put in whatever in the heck you want later on, just FYI. Anyways, I'll go back to putting this as a T because I think I had you guys change it to that. So, all right. So, no issues. And listen, as the guy with the fake pen, I would just say the best habit you can have is to just write it out. Say, okay, here it goes. Input squared minus double input plus 4. And then in place of both of those blanks, I'm simply going to feed the beast. And in this case, it just wants to eat a -6t. So you're going to put -6t here and -6t here. It's very mechanically repetitive, right? So order of operations does kick in at this point in time. What are we going to do next? You have to exponentiate. So the purple jelly bean or the purple, whatever the shape this is, I don't know what that is, but that has to be your priority, right? What is that going to equal?
60 squared.
Say it again.
60 squared.
Nice, good math. Yep. So when you square that, you square both parts of it, and you get 36 and then also t squared. And there's really no law, especially at this level of high school, that would prevent us from doing more than one thing at once. So what is the second portion when we multiply that together?
Well,
Yeah, plus 12t. And then the 4 remains unchanged. You know, constants aren't affected by our inputs. They're kind of immune to all of this stuff that we're doing here. So we would say then that P, I'll just write it down here. We would say that P of -6t equals that. Okay. This next one I think also is very straightforward. The last two are going to be the ones that I worry the most about, but again, I don't think you guys are pretty sharp. So this would be the third algebraic example. So our function's name will be W. He's a machine that processes X's. And his function rule, the mathy part is called the function rule, says to do this. And we are going to find W of m squared. And so I just wanted to make sure on this one that I didn't match on purpose. So again, you can see that my input and my input and my input are matching. But again, the later input, you can, I mean, you're not going to get to pick, like it's going to be decided for you, but just saying. All right. So the best thing you could do, I know that we'd sometimes like to be fast, but the best thing I could do for you is just show you, we're going to take the function and rewrite it. -3 input blank squared minus 5 input blank. And what's going into those input blanks? M squared, right? And there's a lot of mathematical knowledge that you've acquired over your years, and you just put it all to use here. So, what is this first? Let's talk big red amoeba, as Zach put it. What is that going to equal? It is not. It is that. It is -3m to the 4th. You have to pay really close attention to who's part of the exponentiation. In a problem like what I'm putting green around, you have to really focus that the -3 is not part of a squared, right? So he's exempt. Yep. So -3m to the 2 times 2, right? When you power up a power, you multiply them together. And then the last part is, of course, very non-mathy. That's just -5m squared. Good. So we would say that W of m squared is equal to that. So these last ones, I hope I haven't put you to sleep because I kind of need your brains on these last ones. The last ones involve just a little bit more of the notoriously missable algebra. So let's hopefully we don't have any issues here. So our next function, his name is f, and he is a function of n's. And he says, whatever you give me, I will square it, and then I will take it away, and then I will add 1. You might think, well, I don't see why this is like separate. This is what we just did 3 of. Well, it's a little different because we're going to do f of n minus 4. Ugh. So this is always a little bit of a rough spot. Let's take a look. Again, just in its raw, like unmessed with form, we're going to say, okay, I've got this. I'm going to do input squared minus input plus 1. I cannot stress to you enough the importance of that step. Just copy the function down and leave blanks where the input slot is. And what's going into those slots? N minus 4. This is, of course, not really true, but I like to say it. These are the things that keep algebra teachers up at night. No, not true. But still, if things did, this would be on the list. So let's talk colors. I like these amoebas. I don't know if that's the plural of amoeba.
Amoebas.
Amoebas? Can I say that? Amoebae.
I'm pretty sure it's
Amoebu. The
Let's
red
say
one, what's it going to equal?
n squared plus 16.
Yeah, and that's totally wrong, but it's exactly the perfect mistake for you to make. And so this is why I kind of feared this part of the lecture a little bit. One of the most common mistakes you guys make, you guys being just students in general, is that you think that squaring something is as easy as just squaring both parts of it. Now, I will say, in your defense, let me switch colors here. If it was like 4 times n squared, that's when you can just square both parts because the 4 and the n are connected by multiplication. And so you could just call this 16n squared.
So
Oh. Plus,
It comes out to square, square, multiply, double. And it's been a long time since you've heard me utter those words, just when you thought you'd never have to hear them again. But if you don't know where I got n squared minus 8n plus 16, I'll show you. I'm going to convert down here into red, and then I'll erase this here in a moment. Don't ever forget that something squared means to multiply it by itself. So this is what n minus 4 squared really looks like. We're at the point in our lives where we really probably shouldn't keep writing it out like this. Once we refamiliarize ourselves with the square, square, multiply, double, we probably won't need this. But here it goes. When you write out something squared, remember that it takes 4 steps. What is n times n? N squared. What is n times negative 4? Negative 4n. And what is in the middle? Negative 4 times n. Negative 4n. And at the very back end, what is n? Oops, excuse me, I started that wrong. What is negative 4 times negative 4? 16. So I'd really rather not go through all 4 of those steps with you each time, but from this point on, I need you absolutely to promise that you're going to pay really close attention to what it means to square a binomial. And again, it's not as easy as squaring the first term and squaring the second term and then patting yourself on the back. You got to really give full respect to that middle term. Okay. So that's why this lesson, this portion is a little bit scarier. Anyhow, so the red thing came out to that. And then how about purple monster? What's that going to become? Negative n, so minus n and plus 4 plus 1. Just because we're in advanced math doesn't mean we're immune to the mistakes of the past. Like distributing negatives, garbage like that, it can still reach out and get us. So let's simplify this. What are we going to get? And you always want it in order from highest powers of variables and then down the way. What do we have? N squared minus what? Yeah. So we would say in this case that f of n minus 4 is equal to that. Okay. Not difficult, but very missable. You could agree with that. All right, let's do one more. Our function's name is, do anyone want to guess the function's name?
Yeah.
Nope, it's J. Anyone want to guess the input?
B.
Nope, it's R.
the
Well, now it's already done. It's already on the board. And the function is negative 2 r squared. plus 3r. A good noob. And we're going to find j of -2 minus r. Well, let's do x's. Yeah, let's change it. I like that. Let's do -2 minus x. I'm going to call an audible here. Good, good.
Yeah, good noob.
Would you guys like a moment to work on it, or do you want me to kind of coast you through? You pick. You want to give it a shot? Yeah. Okay. I'll pause this. I'll give you guys a minute or so to work through, and then we'll come back together, and then we'll be done. You look like a man that's ready to get. Oh, number 13 is not ready. Anyone else have one? I'm ready. I'm going to write it down. Just that it's because I'm writing it doesn't mean it's right. So good luck. Let's go.
They have -2 minus x. -2x, where -11x.
Thank you for your input. It has been noted.
Sutter got it, then he's probably right.
I guess I can say this on the recording because it's nothing demeaning. I think since we've got 8 or so months left to spend together, just pro tip for all of you, I would generally say this is not take it to the bank. It's just an idea that if you get the same answer as Sutter, you're probably doing okay. Don't let that go to your head, Sutter. Yeah, this is right. This is good. This problem turned out to be a little bit more annoying than I meant for it to be, but let's take a look at the mechanics, okay? So we're going to take, and I cannot stress again enough the importance of just copying the function down like this. There's -2 input squared plus 3 input. Skipping that step will hurt you in the end. And then I'm going to take green and put it in place of both of the input slots. So I'm going to put -2 minus x here and -2 minus x. Good mechanics, good algebra there, boys. That's not simple algebra. So good job. So having said that, we have -2 times something. And I am going to take advantage of this opportunity to remind you about square, square, multiply, double, because it has been a hot minute since we've really gotten to take a good look at this. So I'll color code this for you. There's red and there's purple. Remember the saying square, square, multiply, double goes like this. Start with the red and square it. What do you get?
4.
4. Then take the purple and square it. What do you get? Purple squared. What do you get?
X.
You get x squared, and it's always going to be a plus or a positive because you're squaring things, right? No one really ever struggles with the square square part. It's this pesky middle, and you just have to have faith in the algorithm. The algorithm is multiply double. If you take red and purple and multiply them together, what do you get? Just
2x.
multiply them. Correct. Put red and purple together, you get 2x. Double that, what do you get?
4.
You do. That is a very powerful algorithm to have in your back pocket as you go through your math career. So square, square, multiply, double. It's going to save you some time. But excellent execution there to anyone that got that. And then I'll just copy the rest of it down because we might as well just do all the distribution in the next step. So I'm guessing if you made it that far, you probably would not have botched it from here. That would be, get all the hard part done and then watch it at the end. So you're going to want to distribute -2 and you're going to get -8. Minus 8x minus 2x squared, and then distribute +3, which gives you -6 and -3x. And again, what a shame to get this far and then blow it, combine all that stuff up, right? That's always kind of the last thing we do. So the -2x squared is going to lead the way. We always want to put that power term out in front. And then we're going to take these two yellow ones and put them together, which makes -11x. And then we're going to take our two greens, which are, do you guys remember what the green ones are called again? Constant terms. Very good. So that's a -14. And that's it. So again, that would be j of -2 minus x. So that concludes that. So I'm going to hand out assignment 6. It's just practice with that skill. It's practice with the skill, the art of putting algebraic inputs into functions. And then, because eventually we're going to need to do like, if a function f of x is like the cube root of x cubed minus 4 divided by 2, I need to know if you can put like something into that function. So you can see again how one leads to the other, I would think. So that's that. I'll leave it paused because you might have a question, but that's that.